Most of my pet projects revolve around productivity. The Z Launcher helps you quickly reach various places on your PC, Dev Editor speeds up processing text files, and finally, Log Analyzer aids in, well, analyzing logs. My latest project differs somewhat from the previous ones because it is partially hardware-based. Let me tell you about how it increases my productivity and also how you can reuse a lot of the code I wrote to create a similar solution of your own. My name is Wojciech and you're watching Nonconformist. The device I was talking about looks like this and is called a macro keyboard. It might look inconspicuously, but in reality it is capable of noticeably speeding up your work by automating repetitive tasks. If you use computer to perform various tasks, including work-related, it is very likely that you can identify a set of actions which you need to perform every day, sometimes even multiple times. Such actions may include opening specific locations on your computer, navigating to specific websites using keyboard shortcuts, or launching applications. Most of those actions do not require too much time. For instance, if you need to reach some location on your disk, it usually takes only up to a dozen of seconds to arrive at the destination, even if the location is remote. Similarly, frequently opened websites can be bookmarked, and keyboard shortcuts, well, you can write them all down on sticky notes and attach those to your display. Even though all described actions takes only seconds, these seconds adds up and in the scale of say a year can turn into a noticeable time span. But the time wasted is actually a secondary problem. The primary one is that performing repeatable actions is boring and annoying. Look at it this way. Wasn't the computer invented to help us automate things? So why do we still need to perform the same actions over and over again? This observation led me to writing the Z Launcher. This small application allows you to perform various operations on your computer a lot faster, but still requires some attention from you because to achieve the desired result, you need to write down a specific query. In other words, Z Launcher sacrifices performance for versatility. You are able to achieve more, but you also need to spend some time on precisely defining what you do actually want to do. The ultimate answer for the before mentioned problem is the device I've shown you earlier. Macro keyboard is a small tool resembling a keyboard, but with only a dozen of keys. In contrast to the normal keyboard, however, upon pressing a key, it doesn't simply cause a letter to appear on the screen, but instead triggers a macro which executes some complex action or even a set of actions on your behalf. Sounds nice, but to get the effect described, you need to prepare a little beforehand. Let me explain. First, let's talk a little bit about the hardware. A macro keyboard consists of two main components. The first one are obviously the keys, which you can press. These, both switches and keycaps, are nowadays very easily available for purchase in the internet. It turns out that a lot of people nowadays like to design their own keyboards from scratch. The second component of a macro keyboard is a small microcontroller which detects key presses and then does some magic which results in executing specific command or macro. We will get back to it in a minute. There is a wide range of microcontrollers available on the market, and the most common choices are usually devices compatible with Arduino, because they are very simple to program and use in DIY projects. In my case, I have decided to use Raspberry Pi Pico, a surprisingly powerful and also quite cheap microcontroller. The purpose of macro keyboard is allowing you to execute actions or macros upon a key press. This, however, is actually the tricky part. If you think about it, operating systems are not designed to perform actions upon request made by some piece of hardware attached to your PC, and probably for a good reason. This problem can be solved though, and actually in one of two different ways. The first way is to convince the operating system that the macro keyboard is actually a legitimate input device. There is a set of devices like keyboards, mice and joysticks which are meant by design to be an interface between human and the computer. And most modern microcontrollers, such as Raspberry Pi Pico, Teensy, or Arduino Micro, can present themselves to the operating system as such an input device, or even multiple devices combined. This allows those microcontrollers to send keystrokes directly to the computer, which will react in the same way as if these keystrokes were sent from a real keyboard. This approach allows you to easily automate pressing specific key combinations or key sequences, and you don't even need to install any software on your computer. Unfortunately, this approach is also very limiting. Indeed, you no longer need to remember keyboard shortcuts, because they are reachable after pressing a single key on your macro keyboard, but that's also most of the features your macro keyboard will be able to offer. If you need to automate anything more complex, you either will need to find some workarounds or you won't be able to do that at all. The second approach towards automating stuff with a macro keyboard is a little bit more complex. Instead of simulating an input device, the macro keyboard sends raw data about key presses to the PC. These in turn are being captured by a dedicated application, which then executes desired actions. It is worth saying that majority of commercially available macro keyboards, such as the famous Stream Deck, or maybe a little bit less known Loop Deck, follows this exact approach. Even more, their design is modular, which allows one to extend capabilities of their keyboards by installing plugins containing new actions and macros. Commercial macro keyboards are really fantastic, but their downside is price. The cheapest reasonable keyboard costs $150, and the prices only goes up. Fortunately, there is an alternative of building a macro keyboard on your own. This obviously comes at a different price. You need to obtain some tools and learn new skills, but in the end you can build your own functional keyboard for a fraction of the price needed for a new commercial one. I won't be covering building a DIY macro keyboard in this video, but I'll provide you with some resources which will make this process a lot easier and will allow you to build a keyboard functionally equivalent to the commercial products. I always admired the design of the Stream Deck. Having a display below buttons makes this keyboard an order of magnitude better than others, because you no longer have to bind single action to a key. Depending on the currently displayed screen, buttons can perform different actions. Building such a keyboard on your own is not impossible, but firstly quite complicated and secondly more costly, including time and resources spent on research, trial and error, test builds, software development, etc. Effectively, this can raise the costs so much that it might be easier to simply buy the commercial product instead. I started wondering if it is possible to build my own macro keyboard, which would be significantly cheaper than the commercial products, but still would be functionally equivalent to the Stream Deck. And I figured that the problem may be approached from a slightly different angle. It is obvious that from the two before-mentioned approaches toward building a macro keyboard, only the second one, involving a dedicated PC application, guarantees real versatility. Actually, having a terminal-like keyboard with an intelligent application on the PC has even more upsides. For instance, if the communication protocol between application and the keyboard was clearly defined, then the application could actually work with any macro keyboard, as long as they both use that specific protocol to share information. That's when I started to dream big. What if I could not only create a keyboard for myself, but also a piece of software which would allow anyone to turn their DIY macro keyboards into supercharged productivity tools, just like the Stream Deck. That's how the Open Macro Keyboard project was born, and it has just reached its first fully usable version. To better understand what the Open Macro Keyboard framework is and how you can use it with your own DIY macro keyboard, let's inspect a simplified diagram showing Open Macro Keyboard's high-level architecture. The whole framework consists of four main layers. The first one is the actual hardware macro keyboard. Since my project is aimed at hobbyists, makers, and in general DIYers, this is a device which you need to design and assemble on your own, given that you didn't do that already. The second layer is the driver. On high level, it is a piece of software which serves as a bridge between a specific hardware keyboard and the Open Macro Keyboard application. On the low level, it is a set of merely two classes written in .NET 6, meant for receiving input from the keyboard and then passing it on to the application. And it is where the things start to get interesting. One of my goals was to ensure that integrating a new keyboard to the Open Macro Keyboard framework is as simple as possible. And I believe I have achieved this goal, but the actual level of complexity depends on some factors. Let me explain further. Open Macro Keyboard proposes a standardized protocol of exchanging data with the hardware keyboard through a virtual COM port. Most of the nowadays microcontrollers are able to perform such communication through USB. The messages are exchanged as short text sequences. And so the keyboard informs about key presses and releases and also about encoder-based events, increasing, decreasing, and pressing or releasing the button if it is supported. And the application sends to the keyboard some information about the visuals. For instance, if your keyboard supports backlighting buttons with a color, user can specify a color for a button and the application will pass it through the COM port to the keyboard. The protocol itself is described on the project website. You will find a link in the description. Let's now say that you have a macro keyboard which conforms to the Open Macro Keyboard protocol and also has a generic layout, which means buttons arranged in a grid of size 3x3, 4x3, 4x4, 5x4 or 5x5. In such case, Open Macro Keyboard software provides a set of generic drivers which already support such configurations. You can simply start the application, choose the matching layout, and you're good to go. If your keyboard does support Open Macro Keyboard's protocol, but its layout is non-generic, then you will have to implement your own driver. However, Open Macro Keyboard provides you with some classes, which will radically simplify the process. For instance, if you derive your driver from the base serial port driver class, the whole communication is already implemented for you. What you need to do is mostly prepare metadata to inform the application how many buttons and encoders do you have, what are their capabilities, and how are they laid out. As an example, I can show you the full source code of the most recent keyboard I'm working on. That's actually less than 50 lines of code. And finally, if your keyboard does not support Open Macro Keyboard's protocol, you can still connect it to my framework, but then you'll have to write your own driver. The good news is, however, that the requirements from the perspective of Open Macro Keyboard are really minimal. Actually, there is only one key requirement. Your implementation must call the handle event method when you detect that a key was pressed or the encoder was used. The hard part is implementing the actual communication, but since you have built your own keyboard, that most likely won't be really that hard. Okay, so that was the driver. Let's get back to our architecture diagram. The third layer is a PC application. In short words, that's the hard work done for you, so that your keyboard may become as versatile as humanly possible. The application works in background and can be reached from the system tray. After clicking on the icon, you will be presented with the main window of the application. Firstly, you can add your keyboards here. Let me show you how to add my own keyboard to the application. Add keyboard, choose a driver, configure the connection, and we are done. The next step is to configure virtual screens for your keyboards. This is the Open Macro Keyboards feature, which allows making your macro keyboard so versatile. Simple macro keyboards allows you to execute only as many actions as many buttons do they have. The reason is simple. To be able to switch screens, you need to have some form of feedback so that you know which screen you are currently on. And by screen, I mean current assignments to all keyboard buttons and encoders. Stream Deck and Loop Deck, the commercial macro keyboards, solves this problem very elegantly by providing a screen beneath the buttons, which directly shows you the icons and descriptions of actions bound to a key. But I assumed that majority of users of Open Macro Keyboard won't have the luxury of having a display on their keyboard. So my framework provides you with a feature which allows using different key configurations even if your keyboards have literally no means of providing any feedback information. How does it work? Very simply. If you press and hold any key on your keyboard for longer than 300 milliseconds, A hint screen will be displayed for you just above the system tray on the main display. This screen lasts for 5 seconds, but will last longer if you start navigating while it is open. After the timer elapses, the screen disappears to get out of your way. The two newest keyboards I designed use LEDs to provide some feedback to the user. The Mark II model have LEDs above every column of buttons and also one for every encoder, and the Mark III model, which is still being built, have a LED below every single button. Open Macro Keyboard supports sending such feedback to the keyboard. If your device supports the standardized protocol, it will receive requests to set specific LEDs to given color. As you see, while editing layout of a screen, I can specify a color for any button or encoder, which supports this feature. In the current implementations, drivers will be given all available information about keyboard's element, the description, color, and the image. So if your keyboard actually does have a screen, like the Stream Deck, you will be able to set the underlying images to the ones you set in the Open Macro Keyboard application. However, the base serial port driver class supports sending only color data to the keyboard. And until I design a keyboard capable of displaying images below buttons, I guess it will stay this way. But let's get back to the application. Pressing the OK button saves the configuration and returns to the main screen. Your configuration, including all connected keyboards and their layouts, is stored in the App Data folder in your profile. The 1.0 version of Open Macro Keyboard does not support exporting or importing layouts yet, so be careful when you delete things. The application will warn you if you are trying to potentially shoot yourself in the foot, but it will not prevent you from doing so if you really want to do that. I won't be discussing the application too much. I have put a lot of effort into making it as easy as possible to use, and I think I have reached my goal. Also, if you had the chance to use the application provided for the Stream Deck, you should feel at home. The user experience is very similar. Okay, let's get back to the architecture. The fourth and last layer are the macros. Since one of the core design rules of Open Macro Keyboard was modularity, the macros are also modular. What it means is that if you want to provide your own implementation of a macro, you can simply do it by implementing two classes, enclosing them in an assembly, and then putting that assembly in the Actions subfolder of the application main folder. Your action should appear in the list of available actions and you should be able to use it. Actually, all the actions except system ones are implemented exactly this way. So if you are unsure on how to proceed, simply explore the Open Macro Keyboard.actions.common actions assembly and see how things are done there. This video was a quick tour of the Open Macro Keyboard project. If you need more details, you can reach the project's GitLab page as it is fully open source. The link is in the description. To build the project, you will need Microsoft Visual Studio or, with some more effort, .NET installation along with properly configured Visual Studio code. Note that the community version of Visual Studio is free to use for non-commercial, commercial and small commercial projects, so definitely for this one as well. It is worth noting that currently the Open Macro Keyboard supports only Windows, but I have a plan to use Avalonia to implement a version for Linux. I won't be able to do it for Macs though, because I simply don't own one and frankly not really planning on owning one in the foreseeable future. I am however happy to accept pull requests adding support for Mac computers if someone decides to implement it. If you plan to build a macro keyboard or already own one and want to supercharge it, feel free to use my framework and afterwards make sure to share the effects of your work in the comment section. Good luck! My name is Wojciech and this was Nonconformist.